Hello class. Today we're going to talk about permafrost refreezing, and this will be for the final presentation project. So how the method of refreezing is through thermosyphons. So thermosyphons theoretically are a simple machine that have been around for centuries. Um, they can be commonly found in CPUs, water heaters, and power plants, but they're kind of found everywhere. Thermosyphons operate on the principle that heated fluids rise while cooler fluids sink. This effect is due to the difference in density caused by temperature changes. When a fluid is heated, its density decreases, causing it to rise, and vice versa. Thermosyphons consist of two main parts, the heated section and the cooled section. The heated section contains fluid to be heated, which is heated by a source such as a burner or a solar panel. And the cooled section contains a cooling medium such as air or water, which absorbs the heat from the fluid as it carries away. You can see which creates a cycle. So here you can see the solar panel, which is powering the collector, which is helping push this hot water up into the big hot water tank, and then the cold water is coming back down as hot water leaves. So let's get to the next one. So let's take a look on research projects or where it's been used previously. Thermosyphons were originally used by the U.S. government since like 1964 in a military base in Alaska. They were used to help keep the ground stable. This is what they commonly look like too, by the way, these little spikes coming up. This is actually the pipeline that ConocoPhillips had um, uh, proposed to the U.S. government. So the recent proposal is by ConocoPhillips, which is a large oil company. They had research come out that was showing the direct impact of these oil pipelines and how they are thawing permafrost. They said that they would essentially implement a bunch of these across the entire pipeline to help stop the floor from freezing. Um, so yeah. Its environmental impact, honestly, there really isn't that many negative impacts. They're super simple machines, and especially when they're used by solar power, they don't really affect tons. Um, there is a problem though. They only work in concentrated areas. Um, but beefing these up to large scale. Oh, by the way, these things surrounding the power line are thermosyphons. But as you can see, it takes four to kind of negate the temperature differences caused by the power line. They don't really work when you make them into larger scales because of the energy that is required to get them going. So that's the main environmental downfall. Technical feasibility, again, these are very, very feasible structures. They are currently used in many places in Alaska and other colder areas. Um, they help stabilize buildings and other structures. They are relatively cheap. They are only made up of two uh, two components, and those can be relatively upkept. I mean, especially if you're using solar power. Economic feasibility, again, there are only two components. No external reheating required. You can make them a fully closed system. They're easy to implement and upkeep, which is kind of awesome when you think about it. Social and political acceptability. We're in luck here. They're already accepted and widely used. Simplicity is on our side. Again, they don't require tons of resources. They don't take up tons of size, and again, they don't really impact nature all too much. Down here is a photo of them being used, uh, not recreationally, but on a farm that is helping keep a slope from thawing and sliding, which is keeping all of these buildings in the back intact, which is really, really cool and I think important. Um, yeah, again, there's a problem when they break. When they break and the ground thaws, it can take an extremely, extremely long time for it to refreeze. There was an incident in a women's correctional facility where one of them had broken, and it took 3 years to rethaw or refreeze the ground that they were on, which is an issue. Um, Again, there's not much risk or uncertainty. The only risk is if they break, the ground will thaw, and that could be very hard to bring back. Um, Again, I think they are being used as a crutch to look sustainable by companies like ConocoPhillips because they only work on a relatively small scale. If you zoom out and look at the damage that oil companies are doing to the atmosphere at large, I think there will be more harm caused by oil drilling the than what these thermosyphons can help negate. Again, it doesn't actually help the environment because it can't be scaled up to a large scale. It just helps people in places which do need help and will need help going forward. Conclusion, don't use these for large scale, but they're great for keeping small scale things stable and settled. Um, I am worried about them used for showboating as like an excuse for like, oh, look at us, we're looking sustainable, when in reality they're not. Thanks for watching. Thermosyphons are actually pretty cool. Thanks.